Okay, we're going to use this problem as an example of how to solve a normal probability distribution problem using the Stats Toolkit. So pause the video and read the problem. So for part A, this is how you would set up the problem. A normal probability distribution with a mean of 385, standard deviation of 110. And we're interested in knowing what is the probability of a value greater than or equal to 550. It says 550 or more to 4 decimal places. The probability that x is greater than or equal to 550 is equal to 1 minus the probability that x is less than or equal to 550. So we simply take the probability that x is less than 550, all of this area here, subtract it from 1, and that gives us the area under the curve in this upper tail. Next, we open our Stats Toolkit and go to the Normal Probability tab. In the Normal Probability tab, we're not using the sampling distribution, we're simply using the standard normal probability distribution. So we enter our values here. I didn't show it on the screen, but when you open this spreadsheet, make sure you click on Enable Editing at the very top of the spreadsheet so that you can enter in the numbers. Entering in these values, 385 for the mean, 110 for the standard deviation, and the x value of 550 gives us, in this case, the tool actually tells you the probability of a value greater than the x value, which is 0.0668 to 4 decimal places, it would be 0.0668. Entering that value in and checking it, that is in fact the probability of a fair being greater than or equal to 550. Part B, the probability of a fair $250 or less, we use the same process. Changing the x value to 250 instead of 550, the probability that x is less than 250 is 0.1099 to 4 decimal places. Next, we're looking at the interval between 200 and 500, which we would diagram this way. We want this interval between 300 and 500. The probability that x is less than or equal to 500 but greater than or equal to 300 is equal to the probability that x is less than or equal to 500, all of this area here, minus the probability that x is less than or equal to 300. So we take the area from 300 to negative infinity, subtract it from the area from 500 to negative infinity, and what we have left is the area under the curve within that interval. So first we change x to 500. 0.8521 is the probability that x is less than 500. Then we would change that to 300. And 0.2198 is the probability that x is less than 300. So in calculating these two probabilities, what you get is 0.85209 minus 0.219842. But actually, even for this problem, if you had rounded these numbers to 4 decimal places, it would still result in 0.6323 as the answer. And checking that, that is the answer that the author wanted to see. The last part is to determine what is the cost of the 3% highest domestic airfares, rounded to the nearest dollar. In diagramming this part of the problem, we have a 0.03 probability of airfares falling above some x value. but that x value has some corresponding z value. So we want to find out what is this x value. So using the concept that z is equal to x minus mu over sigma for a standard normal distribution, where we're looking at the entire population, we solve for x. X is mu plus z times sigma. So our challenge is simply to determine what is the z value that corresponds to an area under the curve of 0.03 above that z value. It's important that you use the Stats Toolkit version that is 55 or above. I'm sorry, 56 or above. In this area of the normal probability tab, it lets you find z for a given percentage in the lower tail of the normal distribution. This portion of the normal probability distribution tab calculates the normal standard inverse for a given value, given percentage. In this case, we want 97% because that's the percentage to the left of the value that we're interested in finding. And note that we're dividing that percentage by 100 in order to convert it to a decimal representing a probability. So once we determine that the z value that corresponds to our model of the problem is 1.88079, we plug that into our equation and calculate the x value. That calculation yields 591.89, rounded to the nearest dollar, 592. Of course, what we're interested in is 592 or more.